If you've ever heard me give a presentation before, you know what's coming next. Falcha. Ha mi mojoj a vi koloriev and you.
Got it.
Shogeliker son luk toshikach. Age she teacher hagev. Aun an olive Cory. Toshigishin le rutigen simplik. Kimerachane shiv hello aun an Gallic. Hello. Sconial. Thank you for that. This actually is records. I know you said tuples. I call it tuples. I'm going to call it tuples. If you really have a problem with that, we can talk after. But I'll be saying tuples. Records and tuples, how a slew of new JavaScript features will radically change the way we write code. So if that's not what you were expecting, it'll be fun anyway. My name is Cory Brown. I do work at Omni, where we do incredible, amazing things. And that's all you're going to get from me on that. So you should know this is going to be a fire hose, guys. So buckle up. I'm going to go fast. We're just going to keep moving. If you get lost, I'm sorry. That's why we're recording it. Hopefully we'll get some out of it second or third or fifth time. Who knows? But here's what we're going to talk about. Records and tuples, particularly the pipeline operator, temporal, and pattern matching. There are so many more I could have talked about, but there is just not nearly enough time. And in fact, we may not even get through all of this, but we will try. Briefly on the concept of TC39 stages, this is how a proposal gets from an idea to in the language. There are 4 stages. And that's all I'm going to say about that. So just I'll tell you the stages of each of these proposals as we talk about them, and that'll just give you an idea as to where they are and likelihood of being introduced. So records and tuples, currently at stage 2. Regarding records and tuples, we're going to talk about how they are compared by value as opposed to by reference, as objects and arrays are. How they only contain primitive values. They have a useful toString functionality, unlike objects. They are immutable data structures, and a follow-on proposal, parse immutable. So let's do some demos, sort of demos. As I said, records and tuples are compare by value. Now I got to find my mouse. There we go. As you are probably already aware, if we try to compare 2 objects, oh, of course, now it's not. There it is, yes. Try to compare 2 objects that are the same shape. They are not equal. They're not strictly equal. This is not true with records and tuples. That's kind of a earth-shattering, really amazing thing that just got demoed right there, but you can't know because you haven't had the opportunity to really experience that. I promise you, when you get the opportunity to use records and tuples, that's going to be amazing, and I'll tell you why in a little bit. But the same is also true of arrays. Arrays are dealt with by reference, not by value, but tuples, again, by value. And we can just go a little bit more into that, maybe in a little bit. However, a restriction on them, unlike objects and arrays that can contain anything, records and tuples must contain primitives only. That means strings, booleans, other records and tuples, but they cannot contain objects, cannot contain arrays, cannot contain functions. That is an error. It will not work. The way you can think of it is if it is serializable into JSON. No, if it is in JSON, then it can be in a record and tuple where you're replacing objects and arrays with records and tuples, respectively. Records and tuples, unlike objects, have a useful toString method. So if you were to either intentionally or inadvertently cast an object to a string, what you end up getting in this example is the string of object, 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 object. Very, very useful. I'm so glad they introduced that into the language. This is being corrected with respect to records in that if you cast a record, or a tuple for that matter, to a string, you get something quite useful, which is essentially the JSONification, the stringification of that record. It's not strictly true. JSON stringifies this as an object, and here you'd get the hash sign indicating a record and tuple, which maybe I should have talked about before. What distinguishes syntactically a record and a tuple from an object and array is really just that hash sign in front of it. That that makes it a primitive, means we have a native way of defining them, which is a lot easier. It's something I was hoping for with the map when they introduced map, but didn't come. We are getting it with record and tuple, which is great. Immutable data structures. So folks, it's finally here. You can drop the immutable JS. It's here. It's not here. It's nearly here. Just a demo, you see I can create an object. I can manipulate that object. The properties on that object. I could call object.freeze and object.seal and all those things, but that's very unergonomic and has its own issues. Besides that, you still have the problems of prototypes. What's interesting about records have no prototype. Its prototype is null. So it doesn't inherit from anything. It is a data structure, strictly, which is kind of fantastic. If you see, I can show you what happens if we try to do this. It's a problem. It's a type error. By the way, I'm using the records and tuple playground. So if you guys want to play with that, if you go to the specification in GitHub, it links out to this, and you can type stuff into it. It's got a polyfill. It's pretty awesome. Unfortunately, it's not available in any browser just yet. As I said, it's only stage 2. You can expect to start seeing that when it gets to stage 3, which should be relatively soon. Okay, here's something really interesting. There are a handful of companion proposals that come along with records and tuples, and the first one I want to talk about is the change by copy. So because tuples, and we're going to talk about tuples here specifically, because tuples are immutable, just like records are, and they have a cognitive relationship to arrays, and arrays have certain methods on them that we like to use, map, filter, reduce, those kinds of things. Those are also available on tuples. However, arrays also have things that mutate the array, like sort and reverse and splice. And that is not possible with tuples. And so what we have is the immutable versions of those methods on tuples. We have 2 reversed, 2 sorted, 2 spliced. And then we have this update, which essentially just copies the array or copies the tuple and changes in place the item at the index that you indicate. So you can see if we demo this, you see our 2 reversed, in fact, does reverse the array, or I keep saying that, tuple. Are we supposed to see something? Oh, good heavens. You're right, it's not showing. You'll have to trust me that it is in fact doing those things. I don't know why it's not showing on here, but it doesn't matter. Hopefully this will show something cool. I really hope it does, because this was supposed to be a big moment. But it's its own proposal. And so this proposal is actually adding these features. Nope, didn't do it. 2 arrays. So arrays are also getting 2 reversed, 2 sorted, 2 spliced, and update, which means that now even if you're using arrays, you can use change by copy and not have to change them in place if you're totally into the immutability aspect of it, which I am. So, huzzah. Another supporting proposal in the records and tuple sphere is deep path properties. Unfortunately, I can't demo this one because it's not supported in the playground. Thank you. But hopefully I've got a good example here. If we have an object, a record, and we want to update that record, without this proposal, we can do what's there on line 7, 8, and 9. We can spread that record into a new record. We can deeply go into there and respread the meetup pets and the guinea pig stuff and put it on there. But it gets really unergonomic, unwieldy if we're talking about some really deep paths across many different paths. So this proposal, deep path properties for records, if you look on line 10 there, which will be a syntax error if I try to undo that, what we'll be able to do is give a path to that property and the updated value to it. And that will, so we'll be able to really kind of dive deeply into that thing while we're creating a new record or new tuple. So that's pretty neat. And finally, final supporting proposal that goes along with records and tuples. Oh, I'm sorry, I didn't even tell you guys. I have it up there. This deep path property is in stage 2. Change by copy is in No, that's in stage 3. That's wrong. Change by copy is in stage 3, guys, so it's very likely we're going to get that. Finally, parse immutable. It's exactly what you think it is. It's JSON.parse, but into records and tuples instead of objects and arrays. That's all it is. And that makes working with our data APIs that we want to come back and make immutable, we can do so with JSON.parse immutable. Okay, that's records and tuples. Whew. Not too bad. Okay, we got time. Next, we'll talk about the pipeline operator. Real quickly, who is aware of and excited about the pipeline operator proposal? Yeah, I was too, guys. The pipeline, like I was thinking, and this is probably what you were thinking, there's a pipe function, we can get it from Ramda or whatever. It's nice. And it's going to be very, very nice once we get this baked in the language so that we can just pipe the output of one function into the input of another function. And it's delightful because after all, what else is a pipe operator other than that? Well, we'll talk about that. We're going to talk about why a pipe operator. We're going to talk about the two competing syntaxes for the pipeline operator, the hack versus the F# debate. We'll talk a little bit about the one that won and why the one that won. And then I'm going to give you a few hot takes on that. So why a pipe operator? Well, you guys asked for it, apparently. In the State of JS 2020 survey, it was number 4 on the list of things. However, I'm not sure how much we can trust this because you guys also asked for functions in JavaScript. Okay. But what the pipeline operator is trying to do, the space it's trying to solve for is the consecutive operations, the problem. So we have consecutive operations. We'd like to linearize that, make them a little more ergonomic. And there's a few ways that we handle consecutive operations today. First, with intermediate variables, right? This is the most obvious and also the least desirable way to do it. We do a thing, we store it in a variable. We do another thing and store the results of that in a variable. We pass that variable to the next thing and that we, again, store into a variable. This is great, but it works, but it's not great. One thing that we can do, though, is function nesting. And that's actually really useful because it is very generalizable, right? This can be applied. It doesn't, like, none of the functions that we deal with, none of the stuff has to be aware of each other. There's no, like, orchestration that has to happen at a higher level. It's very generalizable. However, its biggest drawback is it's really hard to read. It reads in reverse order. It's kind of awkward and weird. It's not great for readability. Another option that is great for readability and has a lot of the same benefits that come from function nesting is chaining. And that works really well when you're dealing with maybe a single type that has all of the methods on it that you need, or you're dealing with some kind of like massive global object that wraps everything it returns in itself so that you can continue chaining on it, kind of like jQuery. It works really well, but in that case, you're locked into that. You have to be, if you've ever tried to use jQuery with code that isn't jQuery, it can get a little weird. So the pipeline operator is attempting to take the best of each of these and put them into one syntax that can leave the bad behind and keep all the good. So in trying to accomplish that, there are two competing ideas: the hack style and the F# style. The hack style, the idea is that the right-hand side of a pipe is an expression that contains a special placeholder. And I have the % here. That's actually old hat. Now they want to change. The token is not solidified right now. They're thinking maybe $_ or hat, whatever. But that special token, that placeholder there, represents the result of the previous of the left-hand side expression. So that token is bound to the result of that left-hand side expression on the right-hand side. The F# style, on the other hand, the right-hand side of the pipe is an expression that must evaluate to a urinary function. Each function is called in turn, passing the results of the previous value as the only input to the next. So if you are familiar with the pipe function or functional programming patterns in general, this probably looks familiar to you. It's compose in reverse or pipe forward. That's the F-sharp style. So, in the competition between the hack style and the F-sharp style, what do you think? What style do you think won? You would be wrong. The hack style is definitively the winner as far as the committee is concerned. This is very controversial among the engineers. I'm not joking. Unfortunately, I'm not joking. As the committee sees it, the hack style has a few advantages over F-sharp. With hack style, any expression can be used on the right-hand side, and for F-sharp, only unary functions are permitted. In some cases, the hack style is able to fail early with a syntax error, whereas F-sharp would fail only at runtime. And the hack style already works with async and yield, and F-sharp would have to special case them if they were going to be made to work. Perhaps the most, though, relevant argument that was made is that some members of the TC39 committee, particularly browser implementers, are steadfastly against introducing a language feature that so thoroughly encourages closures and point-free style, which are seen as difficult to optimize. That's probably the most depressing slide in this whole presentation for me, anyway. You should ponder on that thought for a minute. So, some really hot takes. Like many of you, I was very, very excited about the pipeline proposal. And after going deep into it and learning kind of what is almost certainly going to be advanced, if anything is advanced at all, I am now very skeptical that I will ever use the pipe operators, unfortunately. So my thoughts on this are still evolving, though. I wanted, as I said, what I wanted is not what we're getting. And I think a lot of people have that same idea. Those that do care about pipeline, those of you that raised your hand, almost universally think about them in the F-sharp way. Maybe the pipe function that we can create in userland is sufficient. Maybe we don't need an operator at all. Maybe. And that might be even more true if another proposal, the partial function application proposal, gets past stage 1. However, it seems unlikely that the partial application function will proceed for largely the same reasons that the F-sharp pipe didn't proceed. Hack style can be used in more scenarios than the F-sharp style. However, many of those scenarios are, at least in my view, foot guns or just silly. That's perfectly valid hack style pipe. Why you would do that, I don't know. When you can just dot chain, which would be a lot shorter and easier to read, but whatever. Perhaps the community will develop some really interesting and useful patterns with the hack style. And again, maybe the hack style is the compromise that no one wants and no one will use. And I'm worried it will be the latter. So that was depressing. But let's go to something more interesting, more exciting. And we'll have to move through this one real fast. Temporal. It's a replacement for date. Finally, yeah. So, why replace date? Well, we'll talk about that. We'll talk about plain times versus zone times, time durations in arithmetic, and calendars if we can get to it. So, why does date suck? Well, first, there's no support for plain dates and times. Date parsing is discouraged, officially. Date objects are immutable, or are mutable, not immutable. Daylight savings time is unpredictable with the way that it is currently written, and no reasonable support for date computation. No support for Gregorian calendars. This is a cool story. It's going to take some time, but I think it's worth it. As almost all of you probably know, Brendan Eich created JavaScript in like 10 days and was required to like do stuff around Java with it for marketing purposes. And because of that, he totally cribbed the date object from Java. Just took it right out of the language, dropped it into JavaScript. What's a little bit less known is I think the very next version of Java dropped that date implementation. So for all the reasons that we just listed, because it was terrible, and yet we have been stuck with it for 25 years. So finally, we're getting something different. Let's talk a little bit about plain times versus zone times, the distinction that Temporal makes. Zone times are exactly what you might think they are. They are immediately analogous to what the kind of thing the date tries to represent right now. It is a moment in time. It could be reduced if we wanted to down to the nanosecond of an epoch time, right? It's an instant. In fact, we have an instant in temporal. We also have zoned date times. And these will be a lot more easy to work with than date objects, but they essentially represent the same kind of thing. Counter to that, we have something called a plain date and time. So if you wanted to convey your birthday as an object, right? Not as a string, as a date string, but as an object that you can manipulate and add time to and do other things. There's not a way to do that in JavaScript right now because it will be your birth instant, which is not quite right because your birth instant in, Louisiana is actually going to be a different date than your birth instant in Shanghai, which is super weird. So plain dates offer an option for specifying more generalized, less specific timeframes. Duration and arithmetic. Temporal also offers a concept called a time duration, which is what you would think it is. It's not bound to any specific moment in time or even a general moment of time. It is just a duration of time. That's how you might do it. So if we wanted to convert, well, let me back up. A duration expresses a length of time such as 24 hours, 30 seconds, or 525,600 minutes. And we can we can convert a duration to different units, but if it's anything over a month or a year, we actually have to do it relative to a specific date, to a zone date time, because of the way that time works with leap years and whatnot. So we have to include a relative to, which I've done an example there. We're not going to get to the best parts, but there are, we'll skip over that, but we can do arithmetic with dates. And here are some of the really cool methods that we can do with temporal dates. We can update them, we can add, subtract, we can negate absolute value of them, round them to a specific unit, and get a total representing them. Some other methods that are worth pointing out, the toString and toJSON methods are synonymous. They're like aliases for each other, and they produce an ISO 8601 string. toLocale string produces what you'd think. If you give a duration, call toLocal string on there, you get a 1 year, 3 months, 5 days, for example, right? But in the language that is pertinent. And finally, value of is always going to throw on an instant because they are not you cannot compare them with relational operators. Whew. Calendars. You can have more than Gregorian. The ones that are available can be found on the INTL datetime format on MDN. They're all listed there, but you can also create your own provided they adhere to specific certain invariants. They're really cool. You could create custom ones or missing ones, Mayan calendar on there if you wanted. Right now it's on stage 3, and the only thing blocking it is official adoption by the IETF body for the ways in representing the strings of these things. Upon completion, that should happen before November 5th at the next, or on or before November 5th at the next meeting that they have. Upon that, it is only required that 2 JavaScript engines have an implementation in place outside of a feature flag, which I think some of them already do, but behind a feature flag. So I am personally hopeful that we will have temporal available to us in the next version of JavaScript. And we're not going to be able to get to pattern matching. Less than a minute left. Pattern matching is really cool. Let's see it's kind of like a lot of things, but also not like them. They're really, let's see. Let me break it down for you. Pattern matching isn't coming anytime soon. It's too complicated, but what is happening is it's breaking down into smaller pieces into incremental parts. The first of which is this extractor pattern, which is kind of cool because I really want to show you guys this one. It means that if we want to do some validation or transformation, right now we have to do that outside of our destructuring in the top, right? So in the function body, we have to do the validation, we have to do the transformation, whatever. With extractor pattern, we can, as we're destructuring, we can validate and or transform what's being passed in, which is going to be super cool, I think. But that's in stage 1. So those are what we talked about. Here are some things that we weren't able to talk about, which are also very cool. And I suggest you look them up. There's a lot coming to JavaScript, hopefully soon. Top of life.